Today I'm going to talk briefly about different engineering majors. A lot of this information you can find online, and it's also a good resource is your book itself. All right, so we talked about engineering itself. It's the profession in which a knowledge of mathematical and natural sciences gained by study and experience and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. And I kind of like that definition. And we talked about this earlier in the semester. Some things about engineers also is essentially that we are problem solvers, and we solve all different types of problems based on what field of study we're in, right? And we have a large emphasis on math and science and economics. The social sciences and cultural values is also important to us, all of which makes engineering really an applied science for us. The economics is to make sure that everything is financially stable for companies, and we need to think about the cultural values, and because not everything in the U.S. is the same everywhere in the world, right? So the way we drive cars are different in different places. Again, the whole idea of this applied science. If you remember, we also talked about when we talked about the history of engineering, we talked about this tree, and we're going to kind of go through some of these different disciplines within engineering. The first one is civil engineers. Civil engineers build a lot of different things, from bridges and roadways to large buildings and structures to dams, even the water treatment and water management type systems. All of these are the responsibility of the engineers. So they're really responsible for the construction of large scale products, right? They consider, of course, cost, right? Because tax dollars are paying for a lot of these public structures that are being built. Scheduling is really important, right? We think about roads and always having been done in the summer, and can it be done before winter starts and everything. Regulations are involved in the environment and hazards. So there's a lot that goes into civil engineering to help society as a whole. Mechanical engineers are the next kind of oldest ones, of course. Engine and mechanical, right? We think of engines themselves, transportation, different modes of transportation, petroleum or energy resources, whether it's petroleum or wind or solar. We think of manufacturing and robotics. And then there's also the area of fluid mechanics and thermo and heat transfer type areas. All of those are within mechanical engineering. There's three main areas of design, manufacturing, and then this whole energy part is all part of mechanical engineering. Of course, it was born during the Industrial Revolution. Machines are involved in most aspects of our lives, and that's what we're kind of really involved with a lot of. And we have these, again, these main areas. HVAC, which is heating, ventilating, and air conditioning, is also a big part of it. So these are the areas that mechanicals are typically involved with. Again, helping society, right? Advance society. Electrical engineering is another very popular engineering degree. It has to deal with power transmission, computers and computer technology, analog motors, digital systems and applications, manufacturing and controls, and of course communication, right? So we've got power transmission and communication. It all really started with the electric grid and the telegraph, right? Systems for communication and power transmission. Those are the two main functions of electrical engineers. And they have a lot of different areas of specialty, power generation, transmission, motors, electronics, computers, communication, instrumentation and measurements, automation, right? Automatic controls. Those are all different areas of electrical engineers. It also can get into computer engineering, software engineering, sometimes are within the electrical engineering discipline. Another area is chemical engineering. There's a lot of manufacturing done within chemical engineering, creating large volumes of chemicals. Could be for the food industry or dye industry or fragrances. And of course, the petroleum industry is another big area for chemical engineers. So it was really a combination of mechanical engineering and an industrial chemist is how chemical engineering came about. So these are some of their main specialties. Of course, the fine dyes and foods and fragrances and flavors and food. Of course, they too are involved with safety in the environment, and they are design engineers, but in the chemical realm of things. Industrial engineers or industrial and systems engineers. We have now with the PEP program, Platteville has the industrial and systems engineering program, also with mechanical and electrical. And they deal with the layout and format of manufacturing lines, optimizing for those. They also deal with ergonomics, making sure things are ergonomically set at the stations. And we do time studies as industrial engineers also to make sure that the flow is consistent throughout the manufacturing plant. They could do robotics and things like that also. So they are really a bridge between the engineering and management area. They develop, design, install, and operate integrated systems of people and machinery, really looking at the production of goods and services. They're also involved in a lot of logistics and things like that are part of their area. Aerospace engineering, of course, is founded through the Wright brothers in that era, deal, of course, with airplanes, space travel, spaceships, rockets, missiles, drones, all that type of things. That's all aerospace. A lot of times, the aerospace engineering is a subset of mechanical engineering, and it can be found in that area. Aerospace engineering combines mechanical with emphasis on design, development, manufacturing, but it's really through the aircraft, spacecraft, and missile type technology, right? Propulsion. Controls engineering is also part of it. If you're interested in aerospace engineering, I would also recommend, instead of maybe going into that field itself, sometimes it's really hard to get into, is to get your degree in either mechanical or electrical and get some emphasis courses in that area. So that's another way of getting an aerospace degree. Materials engineering is also really important. It deals with all different types of engineered materials, from ceramics and plastics to metal alloys, are all part of materials engineering. The whole petroleum and mining is also part of materials engineering. So it's really obtaining the materials that are used for society. It could be geological, mining, petroleum, ceramics, plastics, like I mentioned. All these are parts of the material engineering area. Next, we have agriculture. Agriculture deals with the production of fiber and food sources, the equipment to do it, the hydrology of it all, just to really help farmers efficiently produce food and fiber and apply the knowledge of mechanics and hydrology. Computers now, of course, with GPS and everything, electronics, chemistry, and biology. It's all that whole combination is part of the agricultural engineering area. Next, we have nuclear engineering. Of course, we have nuclear energy, and we also have medical areas for nuclear engineering. We have Shine Medical and North Star Engineering, which is right in our backyard in the Janesville, Rock County area, deal with these medical isotopes. And here we have Homer Simpson trying to control the nuclear power plant. Oops, bye, Homer. So, of course, there's also the design of nuclear power plants, ships, spacecraft, of course, have nuclear power also, and, of course, nuclear medicine. Nuclear medicine, of course, like here, they're developing different seeds and things, nuclear seeds, which are used to be injected into the body, which have short life. but these little pellets or seeds are put in to the sources of the cancer to kill off the cancer cells. We have architectural engineering. Milwaukee has really the biggest area for that. Here we have the Brewers Stadium. Was a big architectural marvel in itself with the roof and everything. They also deal with acoustics and home. It's really combining the whole idea of engineering knowledge and structures with materials and acoustics for form and function and aesthetics of buildings themselves. Next, we have biomedical, and biomedical is a large area also. I worked in the biomedical industry developing minimally invasive surgical type equipment that you see in here. But prosthetics and other types of things are also in the biomedical area. It's a huge growing area. It too is sometimes a combination of electrical, mechanical, and chemical with the human physiology developed into it. These are the areas and where they work and the areas that some things that they deal with. This too is a very hard degree to get into. The standards are rather high. If you're interested in the biomedical industry, I would highly recommend picking one of these three areas, mechanical, electrical, or chemical, studying that, and then also taking some course in physiology. It gives yourself a lot more openness to either doing biomedical or any other type of engineering within those areas. I do know some companies that hire engineers for biomedical engineering, and they sometimes, typically really and more often, hire mechanical, electrical, or chemical engineers as opposed to biomedical, because biomedical is too broad and they don't have enough in-depth knowledge in one of these three areas. So that would be an area that way you may want to get into that field. I know like Platteville also has a minor in mechanical engineering with biomedical emphasis. Computer science, a lot of times is part of the electrical engineering program. It deals really with the hardware. This is a Cray computer, which at the time used to be one of the fastest computers in the world. To me, it deals with a lot of hardware and things, right, in it. But it also has software involved in it also. But it's really, emphasis is really on the hardware itself. Areas that you can be involved in all of these different ones are research and development. Typically, you'll need a PhD to do the research, development, maybe a PhD, definitely a master's. Design, you don't always need a master's or above, a lot of times bachelor's. My son has a bachelor's degree and he's doing design. When I worked for IBM, I needed really more of a master's degree to kind of get into these areas, which I wanted. So that's why I obtained my master's degree. But you can get into production or manufacturing, testing, construction. All of this can be found pretty much in every different discipline of engineering. Operations, sales. Sales engineering is huge. I know a student that went through the program here and is now a sales engineer for Trane, which sells heating, ventilating, and air conditioning type things. And then also you can get into management, consulting, and of course teaching. I wouldn't recommend teaching unless you really enjoy it, like I do, because it doesn't pay as much as many of the other areas. But it is a good area to get into too, if you like teaching. So the question is, do you do a bachelor's degree or do you get a master's degree or PhD? This graph is very outdated, of course. It's 2005. But it kind of gives you the idea of what's happening here, right? If you get out with a bachelor's degree in mechanical, really, you're probably in the 60, 65 range right now. But this is just kind of an example. But this bachelor's degree, you can start getting quite a good salary coming out without a master's degree. And you could do that for 2 years, right? It takes 2 years at least to get a master's degree. So you gained, of course, here it'd be 65,000 one year, maybe 70 the next or whatever, or 65 again. So you've got, $130,000 that you've earned while you're not making anything getting your master's degree. But you see your master's degree does start out higher. and then will continue to go higher and always be a little bit higher than the bachelor's. This is on average, of course. PhD typically takes 5 or plus years. Of course, you'll get another jump, but you'll be losing all of these years of salary. But then it will, of course, continue to go up. The reason you would pick either one of these is really what you want to do with your career and where you want to go. I wouldn't necessarily base it off of these salary curves and things, because you will make a good salary doing any one of these three and live a comfortable life. But it just kind of gives you an idea about them. Typically, if you get your master's or PhD in engineering, there is money available for you to get those degrees for nothing at all, for free. I got my master's degree for free. They paid my tuition and fees, gave me a stipend, which paid for my room and board. I didn't really make any money, but I didn't lose any money. And then I was working at the time for IBM. I took an educational leave of absence, but they paid for my health care benefits also during that time. So that kind of gives you an idea of the different types of engineering. I hope this helps you kind of narrow down where you may want to go. Always, if you have any questions with anything, let me know and I will get back to you. I really like talking about the different disciplines, and I'd be happy to talk about them with